Ooh, touch up a little bit. To homework help 3.8. All right, the first section of your homework is simplifying radicals, which is very good practice. We're going to scoot you back a little bit. That's only a little bit better. Never mind, come back. Okay, so I'm going to do... I don't know, number 3. I'll probably do 2 of these. So number 3 is there. The square root of 32. So you're just simplifying the radical. All right, that doesn't mean you're turning it into a decimal. That means we're going to find the prime factors of 32. So factors of 32. 16 and 2, 8 and 4. I'll do, probably most of you are going to go to 8 and 4, so we'll do that. We'll do 8 times 4 is 32. Okay, neither of these are prime, so you must keep going. 8 is 4 times 2. This is prime, and then 2. 2 times 2 is 4. 2 times 2 is 4. Okay. I feel like we've dealt with 32 a lot, so you might actually have this one memorized. So the prime factorization of 32, 2 times itself, 1, 2, 3, 4, 5, 5 times. So 5 2s, 1, 2, 3, 4, 5. Okay. Then you're looking for, why are we so zoomed out? Come closer. Ooh, too close. Hold on. Okay. Groups of 2. So I have 2 2s. So I'm going to pull out a 2. So I pulled out a 2. I have 2 more 2s. So I'm going to pull out another 2. And then this last one, he's all by himself, so he stays underneath. So then 2 times 2, 4 times the square root of 2. And that would be your final answer. Okay. All right, number 6 is the square root of 8a. So you're still just simplifying. What if I do this one in all an annoying voice? Okay, let's see. Oh, no. All right, so you have to simplify under the radical. All right, that doesn't mean turn it into a decimal. That means you're going to find the prime factors of 80. So here we go. So 2 numbers you can multiply together to get 80. There's a lot. You could do 8 and 10, 2 and 40, 4 and 20. So many choices. I'll do 8 and 10. But it doesn't matter which one you use. It doesn't matter at all. Factor them. 4 times 2. 2 is prime. 2. There. All right. Do 10. 10 is 5 times 2. Oh, those are prime. All right. Now, just rewrite it under the radical with all of the prime factors. And 5. All right, now you're looking for groups of 2 because this is the square root. So groups of 2. So I have 2 2's. So I pull out a 2, and I have 2 more 2's. So I pull out another 2, and then I only have 1 5. So he stays like that. And then you have 2 times 2, which is 4 times the square root of 5. And that is your final answer for number 6. Ta-da! Alrighty, Rooney Doody. The next set is 8 through 15, and you don't necessarily need to figure out the x-intercepts right. You just need to classify them. But when they give you an equation, you have to at least go through most of the process to find them, because you don't know what they are until you do that. So I'm going to do, I don't know, number 10. X squared. Okie dokie. So, in order to classify the x-intercepts, you should probably just find them. All right, so you can, well, first of all, we're going to set this equal to 0. Because we're trying to find the x-intercepts, and for our x-intercept, y is 0. That's why we always set it equal to 0. And then you can solve this by factoring quadratic equation, completing the square. I think, if I remember right, you can factor this one. 12 and 2, 8 and 3, 6 and 4. I guess you can't. Okay, so then we can either complete the square or quadratic equation. You can do either one. I'll complete the square. All right, so I'm going to move C over, so I'm going to add 24 to both sides. You don't have to. If you want to do it all on one side, you can. I just like this better. So I'm going to have x squared plus 4x equals 24. Okay. Now we're going to complete the square on this side. So x squared plus 4x plus equals 24 plus whatever I add on over here, I also have to add on over there. All right. So complete the square. Take half of b and square it. Take half of b and square it. So that's 2. Half of b is 2. Squared is 4. I'm having deja vu. Oh, so they did this. Never mind. Never mind. It makes sense. So then, on this side, you can write this in its factored form, which we just made this a perfect square, so you can just take half of your middle term. So x plus 2 squared equals 28. I feel like I have done this one a lot. Huh. Anyway, you're solving for x, so you're going to take the square root of both sides. So that gives you x plus 2 equals plus or minus the square root of 28. As soon as you know what the classification is going to be, you can stop solving, but we're going to keep on keeping on. I mean, as soon as you, because when we first started this problem, I tried to factor this. So I tried to think of factors of negative 24 that add up to 4, and there weren't any. I automatically know that it's not going to be whole numbers then, right? And it's not going to be integers. Because if it was integers, then I would be able to factor this. Just by thinking of two numbers that multiply together to get negative 24 and add up to 4, but there weren't any. So it's not going to be whole numbers and it's not going to be integers. So it's probably going to be rational or irrational, but we'll keep going. So then, we have to do 28. We'll come over here. Yeah. 28, which is 7 times 4 This is prime, 2, 2, prime, prime. Okay, so square root of 28 is the same thing as 2 times 2 times 7. Looking for groups of 2, so take out a 2, and then your 7 stays inside. All right, okay, so it's going to be 2 square root 7. No, this problem was on the homework. Am I doing the wrong homework problems? Hold on. No, I'm doing 3 point. Did we have this exact problem on our homework? X squared plus 4x minus 24. No. Okay, well, whatever. So you're gonna subtract, oh, I'll rewrite it over here, my bad. So x plus 2 equals plus or minus 2 square root 7. 2 square root 7. Subtract 2. So you get x equals negative 2 plus or minus 2 square root 7. Whew! Really? As soon as, well, I don't know. Once you're here, you're like, okay, I'm going to have the square root of 7, and the square root of 7 is irrational. So these are going to be irrational numbers. Do I agree with the book? That's always important. I do. So number 10 is irrational. Because we can actually do it. If you take the square root of 7, like if you put that into a calculator, it is, hold on, I'm doing it right now. Square root of 7. Okay. So the square root of 7 is 2.6457, and it goes on forever. Okay? So this is irrational. It's a decimal that goes on forever and never repeats. So this is irrational. Even if you multiply this by 2 times 2. Okay, because this is technically multiplied by 2, then you still get 5.29150, etc. Okay, so it goes on forever. So this is irrational. Okay, 10 is irrational. Okay, if you need help on classifying numbers, I posted a YouTube video on Canvas that I liked that goes through natural, whole, integers, rational, irrational numbers. All right. I'm trying to think if I want to do another one of these. Number 12, they give you a graph, but they also give you the equation, so you have to use the equation to figure out what they are. Okay, looking at the graph of number 12, one intercept is 1, but the other one you can't tell. I wish I could share it with you. I wonder if it's helpful if I hold it up. Probably not. Oh, no, sort of. That's fine. Okay, so 12. Okay, so you're looking at number 12. So one of the intercepts is positive 1, right? But then the other one is in between. And so the only problem with that is you know it's not a whole number because it's in between, right? So it's either rational or irrational, but you don't know which one. All right, so you would have to solve this to figure out your x-intercepts. Okay. Okay. And if I were you, I would do it using the quadratic equation. I guess I should do one of them using the quadratic equation. Oh, we'll do number 15. That's fine. It is 3x squared minus 5x. 3x squared minus 5x plus 9? Question mark? Yes. All right. So it says f of x, or h of x, but you're going to put it equal to 0. And then, yeah, the easiest way to factor this guy, or to solve this guy, is by using the quadratic formula. Let's do it in purple. All right, so where are we? So A is 3, B is -5, and C is 9. Here we go. So it's going to be 5 plus or minus B squared, which is -5 squared. -5 times -5 is 25. Minus 4 times A, which is 3, times C, which is 9. All over 2 times A, which is 2 times 3, which is 6. All right? Okay. 5 plus or minus 25, and then you multiply these together. -4 times 3, that's, sorry, there's a glare. -4 times 3, that's -12 times 9. Twelve times 9, uh-oh. That's a basic fact, I can't think of it. 12 times 9. That's sad. That shows you my brain's starting to go. 12 times 9. 108. Wow. So this is minus 108 all over 6. We'll go one more step. So 5 plus or minus 25 minus 108 is -83. Okay, -83 all over 6. You could stop here. You already know. Okay? You cannot take the square root of a negative number and get a real number. You cannot take the square root of a negative number and get a real number. You cannot get a real number. Therefore, if you cannot get a real number, what is your answer for classifying these? You cannot take the square root of a negative number and get a real number. Therefore, they are not real. Not real or imaginary, right? So you would label number 15 as not real. All right. Okay, I said this in both the classes, but 16 through 18, you're just determining the number of roots that each polynomial will have, right? And that's just based off the highest power. So I think I did this in class, but that's okay. Do 16 real quick. So 16 x to the 5th plus, let's bring it up here, boop, plus 7x cubed plus, oh no, minus x squared, geez, plus 4x minus 21. All right, so the number of roots that a polynomial will have is just based on the highest power. So what is the highest power of this polynomial? What is the highest power? 5. The highest power is 5. I have a power of 3. Sorry. I have a power of 5. I have a power of 3, 2, 1, and nothing. Okay? So, going off the highest power, so there will be 5 roots. That doesn't mean they might be a mix of real and imaginary, but there will be 5 roots. So 3 of them might be real and 2 of them might be imaginary, but there will be 5 of them total. So it's based on the highest power. All right. Okay. 19 through 27. Okay, it says if the given quadratic function can be factored, then factor and provide the x-intercepts. If you cannot factor the function, then use the quadratic formula. So if you can factor it, then do so. That's easier than using the quadratic formula. For instance, number 19, you can factor to find the x-intercepts. I'll do 27, and then I'll go back to one that you can actually factor. Because you cannot factor this one. You can't factor it. You have to use the quadratic formula. Don't let the fact that there's only 2 terms freak you out, all right? We're going to use the quadratic formula, so we have to label A, B, C. All right, so what is A? Look at your expression, or sorry, your equation. What is A? A is with the x squared. A is always with the x squared. Remember, A is all powerful. It goes with the highest power. So A is x squared. So that's 3. B is best friends with x. B is best friends with x. Well, there's no number here with just an x. So that means, what does that mean? Don't say it's 1 because it's not 1. There's no number, there's no b of x term. So it's 0. And then c is the term all by itself, so it's negative 11. Right? So you can always rewrite this and fill in the missing term. So 3x squared plus, because really we're looking for this, ax squared plus bx plus c, right? We're looking for standard form. There is no b of x. That means it's 0. Because 0 times x is 0. That's why it's not there. It's 0. B is 0. And then this is minus 11. So that's C. Okay? If it's not there, that means it is 0. So you need to know that going into the quadratic formula. Now we can fill it. Let me write down. Since b is 0, let me try it down. So it's negative b plus or minus square root of b squared minus 4ac all over 2a. All right. There's your formula. B is 0. So 0 plus or minus 0 squared minus 4 times a, which is 3, times c, which is negative 11. Oops. All over 2a, which is 3, so 6. You don't have to show this part. I was just showing you. I'm still substituting in like normal, but obviously you don't have to write the zeros because they don't do anything. So there's 0, so that's nothing. So really all you have is plus or minus. We don't even need that, I guess. But yeah, you do, because it's going to be positive and negative still. The square root, 0 squared is just 0. So you have negative 4 times negative 11. Woo. Which is positive 44. Positive 44 times 3. Can't do it in my head real quick. 3, 12, 13. Okay. 132. All over 6. Okay. I think 132 is that. No, it's not. 11, 12, 27. Okay. So we have to factor 132. Bummer. Because we have to reduce the radical. Oh, yeah. Okay. So 132. It's going to be, I don't know, let's see, 2 times I remember. Instead of pulling out a calculator, let me just do it. See if I can get to the answer. 132. 2 times 6, 12, 1, 2, 6, 66. All right, 2 and 66. This is prime. This is not. 6 and 11. 3 and 30. 2 and 33. Let's just do 6 times 11. This is prime. This is not. 3 times 2. There we go. Oop. So you can rewrite. I'll do it over here. The square root of 32, you can rewrite that as, we have 2 times 2 times 3 times 11. Right? Looking for groups of 2. 1, 2, pull out a 2. And then these have to stay inside. So you have 2. 3 times 11 is 33. All right. Okay, I'm going to erase this part. So you have plus or minus 2 square root of 33 all over 6. Just think of it as, you can reduce it as a fraction. So I can divide both of these by 2. Just think of it as simplifying a fraction. So I get plus or minus 2 divided by 2 is 1. So that's just square root of 33 over 6 divided by 2, which is 3. Hopefully I match with the book. Yes, I do. All right. Okay. This is number 23. So if you can factor it, factor it. If not, you can use the quadratic equation. You can always use the quadratic equation. It will always work. But if you can factor it, that's typically faster, right? So we need factors of negative 40 that add up to positive 3. So here, I'll do factors and whatever they add up to, so the sum. Can you see this? Yes. All right, so factors of negative 40. Well, I have 1 and negative 40. If I multiply those together, I get negative 40, but if I add them, I get negative 39. I need to get 3, so that's not it. All right, what about negative 40 and 1? Oh, I just did that. Positive 40 and negative 1. There we go. They multiply together, so you get negative 40. But do they add up to 3? No, you get positive 39. All right, what about, there's also 10 and 4, but one of them has to be negative, so 10, negative 4. Multiply them together to get negative 40, but you add them up and you get 10 plus negative 4 is 6. Okay, that's not it. What about negative 10 and positive 4? Nope, then you get negative 6. So let's do 8 and negative 5. If you multiply those together, you get negative 40. If you add them, you get positive 3. So there you go. Those are your 2 factors. So e of x minus, oh yeah, x minus 5, x plus 8. Okay, now you have it in factored form, but you need to know the x-intercepts. So it would be x equals 5 and negative 8. Because if x is 5, 5 minus 5, that makes it 0. And so this makes the whole thing 0. Remember, when we're trying to find the x-intercepts, we always put our equation equal to 0. When you're trying to find the x-intercepts, you always put your equation equal to 0. And then you try to figure out what value of x will make this equal to 0. 5 and -8. All right. Okay, I think that's all I'm going to do for you. Yes, it is.